Hi, for this recording, I will help you to show you how to determine how to find the greatest lower bound of the set E. In this case, E equal to -2 plus 3 over n squared, where n equal to 1, 2, 3, 4, and so on. In this case, we must know what is the meaning of definition of greatest lower bound of a set. Now, according to David Brannan analysis book, page 26, definition says that a real number m is the greatest lower bound or infimum of a set E from a set of real number if, first of all, this number m is lower bound of E. This means that m is less than everything in E. And another condition is if you have another number m prime greater than m, then m prime is not a lower bound of E. Any number greater than m is not a lower bound of E. In this case, we write m to be the infimum of E in this case. The strategy of determine a lower bound of E is first, in page 27, is first check that the number m is a lower bound of E, means m is less than or equal to x for all x inside E. And if m prime is a number greater than m, then must be able to find some x in E such that x is less than m prime. So in that case, m prime is not a lower bound of E now. So now let's go back to the question. You're going to find the greatest lower bound of the set E. So to do this, if you look at our strategy, first we must show that m is a lower bound of E first. Means m is less than everything in E. So first of all, what is m now? So it must be a guess first. Guess. So the guess is you guess the number m. So what is m look like? Since we know that everything in E look like -2 plus 3 over n squared, and this number sure enough is definitely greater than -2, right? Since 3 over n squared is positive, therefore you can guess that the infimum of E is -2. So m equal to -2. Now, how do we verify that this is an infimum of E? Number one, first of all, anything in x look like this, -2 plus 3 over n squared, sure enough is greater than -2, right? Therefore, -2 is a lower bound of E, since everything in E is greater than -2. Now, secondly, if I have a number m prime greater than -2, greater than m, right? Greater than -2, then I must show that this m prime is not a lower bound of E. Now, how do I show that? Now, everything in E look like this, -2 plus 3 over n squared. I want to show that this is less than some m prime. This is less than m prime for some n. Okay, so that I want to show that this m prime is not a lower bound of E. That is to show, right? I want to show the objective is want to show m prime is not a lower bound of E, right? So in this case, you can say, all right, anything in E look like -2 plus 3 over n squared. I want it to be less than m prime for some n now. When did this happen? This will happen if and only if I try to make n squared the subject now. So 3 over n squared is less than m prime plus 2. Since m prime is greater than minus 2, so m prime plus 2 is greater than 0 now. So I can continue the argument. This is, since both sides are positive, since I know that because m prime is greater than minus 2, since 3 over n squared is positive, and m prime plus 2 is positive as m prime greater than minus 2. So by reciprocal rule of real number, I know that in this case, this is the same as equivalent to, the inequality is equivalent to now n squared over 3 greater than 1 over m prime plus 2, and multiply both sides by 3, the same as n squared greater than 3 over m prime plus 2. Since 3 over m prime plus 2 is a positive number, I can take the square root. So this is same as if and only if n greater than square root of 3 over m prime plus 2. This means that the original inequality, if I want that minus 2 plus 3 over n squared less than m prime, then my n must be greater than square root of 3 over m prime plus 2. Is it possible to find such an n? Yes. According to the Archimedean property of real number, which is on page 7, if a is a real number, any real number, then I can always find a positive integer n such that n greater than a. So in this case, my real number in this case is square root of 3 over m prime plus 2. This is my a here. Alright. So is it possible to find a real integer, positive integer greater than this a here? Yes. Alright. Such integer exists. So I can say that such integer exists by the Archimedean property. So there is n0 greater than, n0 is a positive integer, right? There is a positive integer n0 greater than square root of 3 over m prime plus 2 by the Archimedean property of real number, which I say here, Archimedean property of real number. If every number a, I can always find a positive integer n greater than a. So if this is true, then we can trace back to find out at the above inequality, this inequality, that the minus 2 plus 3 over n squared less than m prime. That means that is, I know that there is an n0 such that minus 2 plus 3 over n0 square is less than m prime. That means, but minus 2 plus 3 over n0 square is in E, right? As minus 2 plus 3 over n0 square belong to E. So m prime is not a lower bound of E. So in this case, what is m prime? M prime is a number greater than minus 2. So as long as a number greater than minus 2, it is not a lower bound of E. So the conclusion is now the greatest lower bound of E is minus 2. Or we write infimum of E is equal to minus 2. That's the end of the recording.